Okay, so this is a continuation of what we previously did. We're still doing review number 5. There's just 2 more questions on the back. So, question number 5 says 2x squared plus 8x equals negative 7. So, just like we've been doing, we want to bring our 7 over to the other side. So we have 2x squared plus 8x plus 7 is equal to 0. And remember, we're doing the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Our b is 8, our c is 7, and our a is 2. So x is equal to negative b. So negative 8 plus or minus the square root of 8 squared minus 4 times a times c all over 2a. So x is equal to negative b plus or minus the square root. 8 squared is 64 minus 4 times 2 times 7 minus 56 all over 2 times 2, which is 4. X equals negative 8 plus or minus the square root of 64 minus 56 is 8 all over 4. This simplifies to negative 8 plus or minus 2 square root of 2, because 8 is equal to 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. So then this square root, this simplifies to 2 square root of 2 all over 4. So we can either write it as x equals negative 8 plus 2 square root of 2 over 4, or x is equal to negative 8 minus 2 square root of 2 over 4. Remember, plus on one side, minus on the other side. And the question is asking, remember how before we had to round? Well, we have to round again because the question says round answers to the nearest hundredth as needed. So that's why over here we did hundredths. Now here we're going to also round to hundredths. So x is either equal to negative 1.29 or x is equal to negative 2.71. These are our 2 answers. Okay, the last question we have. A ball is catapulted upward from the top of a building at a speed of 30 feet per second. The ball's height above the ground can be modeled as h of t is equal to negative 16t squared plus 30t plus 40. How long does it take for the ball to reach a height of 50 feet? So we are going to do the quadratic formula, the formula. We need to take our equation. So h of t is equal to negative 16t squared plus 30t plus 40. So the main thing with this is that it says how long does it take to reach to a height of 50 feet. So how long? We're trying to find t. We don't know what t is, but we know h of t will be equal to 50. We are trying to find the t. So we can set our equation up here equal to 50. And we get 50 is equal to negative 16t squared plus 30t plus 40. Then we bring our 50 over, so we have 0 is equal to negative 16t squared plus 30t minus 10. And now we're trying to solve for t. So instead of our Pythagorean theorem, our quadratic formula of x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, we have our t is equal to it. So t, first let's find our a, which is negative 16, our b, which is 30, and our c, which is negative 10. So t is equal to negative b, negative 30, the square root of b squared minus 4 times a times c all over 2a. So let's simplify it. T is equal to negative 30, the square root. 30 squared is 900, minus 4 times negative 16 times negative 10 is negative 640, all over 2 times negative 16, which is negative 32. So t is equal to negative 30, the square root of 900 minus 640, 260, all over negative 32. So now we have to simplify it to the nearest hundredth. So we get t is either 0.43 or t is 1.44. So those are our two values for t. And what are the units? Well, in the problem we said, what did we say? 30 feet per second. So time is in seconds. So 43 seconds or 1.44 seconds. So what do we think the answer is? Because we have two times. Is it both times? Can it be both times? Well, let's look at the context of the question. The question is asking, how long does it take for the ball to reach the height of 50 feet? So remember, we're throwing it up and then the ball has to come down. So the 43 seconds, the 0.43 seconds is when we throw the ball up. And then the 1.44 seconds is when we throw the ball down. So those are our answers. So both are correct. They just mean different things. One is when we throw it up, and then that's when the ball is coming down. Okay, so that's the end of prerequisite 5. So let's go to prerequisite number 6, algebraic manipulation. So the algebraic manipulation, again, we're talking about throwing a ball straight up. So the question says a ball is launched straight up with a velocity of 40 feet per second. The ball's height above the ground can be modeled by this equation. Use this information to answer the following questions. So, how high is the ball when it's released? So let's think of this logically. When we release the ball, we're releasing the ball. Say you're throwing the ball and the units are in feet. So when we're throwing the ball, you're throwing it at a certain height. You're not throwing it from the ground. You're throwing it from where your hand is. So when we throw the ball, time is 0. No time has passed yet. So to figure out what the height of the ball is, we just set our h of t when our t is 0, and we solve. So every time we see t, we set it equal to 0. So when we're copying our equation from up here, negative 16 times 0 squared plus 40 times 0 plus 5. So h of 0, when no time has passed, is 5. So what this means are 5, and remember our units are feet per second, so since we're talking about the height, it's 5 feet. So what does this mean? This means that the ball is 5 feet high when it's released. That's what this means. So how long does it take for the ball to reach its maximum height? So when we're talking about maximum height when we're throwing the ball, if we have a graph, and this is our x and our y axis, and remember, we're throwing the ball at 5 feet. So say this is 5. It's going here, and our graph is going to look like this. It's going to look like that. The maximum height is its vertex. So there's this specific equation that we use when we're trying to figure out vertex, and it looks like this. Negative b over 2a. This is how we find the vertex. So we just plug in our values. Our b is 40, and our a is negative 16. So now we're going to plug it into this equation. Negative b, so negative 40, all over 2a, which is negative 16. So then this becomes negative 40 over 2 times negative 16, negative 32, which just simplifies to 1.25. And remember, units. We have to always remember units. Especially when they indicate units, you have to write the units. So for this, how long does it take to reach the maximum height? We're talking about height, so it's going to be 1.25 feet. Okay, so question C asks, what is the maximum height the ball reaches? So we found in B the maximum time. We said that the maximum time is 1.25 seconds. So now we're going to use this maximum time that we got, and we are going to figure out what the maximum height is. So we're going to take our equation, h of t, when our t is 1.25, and then every time we see a t in our original equation, we will plug in 1.25. So we have negative 16, and then that's where t is going to go, plus 40 plus 5. So our t, remember, is 1.25, so negative 16 times 1.25 squared, plus 40 times 1.25, plus 5. So negative 16 times 1.25 squared, this becomes negative 25, plus 40 times 1.25, which is 50, plus 5. So 25 plus 50 plus 5 is 30. And 30 what? So, okay. Remember, our equation, so 16 times 1.25 is actually going to be negative 20. So that means that our answer is going to be 35, because negative 20 plus 50 plus 5 is 35. And what is our units? Remember, units. What is the maximum height? Feet. 35 feet. Okay. So now we're trying to figure out how long is the ball in the air. So if we look at our graph above, this is our graph. It gets thrown at 5 feet. It's this point here, our vertex, remember we said is 1.25. So now we're trying to figure out where it crosses our x-axis, and then what is our y value. So we said we're crossing the x-axis, so our height, our h of t, is equal to 0. Our height is 0. Because remember, this axis over here, this is our h of t axis. This is our t. So our height is 0 is right here. So we're trying to figure that out. So let's set our original equation, remember our original equation, equal to 0. Negative 16t squared plus 40t plus 5. So what are we going to do? Quadratic formula. A is equal to negative 16, B is equal to negative 40, and C is equal to 5. What is the quadratic formula? T is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. You guys should be reciting this in your sleep now. I've said it so many times. And I hope you guys are following along and saying it too when I'm saying it. So, T is equal to negative 40 plus or minus the square root of B squared minus 4 times A times C. Oops. All over 2A. All over 2A. So, what does this simplify to? Well, we did T is equal to, so negative 40, negative times negative 40 is positive 40, plus or minus the square root. So 40 squared minus 4 times 16 times 5. This all simplifies to 1,920, big number, all over 2 times negative 16, negative 32. So, to simplify this to the nearest hundredth, we get two values. We get either T equals 40 plus square root of 1920 over 32, or T is equal to 40 minus the square root of 1920 over 32. So this simplifies out to either this simplifies out to either time is equal to negative 0.12 or T is equal to 2.62. So let's take a moment to look at our answers. Can we have time, negative time? No. So this answer, incorrect. So what is our answer? The positive one, 2.62 seconds. And we know it's correct because if we go back up to our graph really quick that we kind of roughly drew, we knew that our answer has to be greater than 1.25 because that's when the vertex is. So that's why we kind of know that this is our correct answer. 2.62 seconds. Okay, so now question prerequisite. We are doing prerequisite, oh no, sorry, we're still on the same prerequisite. We're doing question 2. So, a child uses 36 Legos to build a rectangular frame for the base of her Lego castle. Rectangular, 36. Write a quadratic function to model the situation and determine the length of the side of the castle and the largest possible area covered by the castle's base. Okay, so this is a lot. Let's break down the first sentence. A child uses 36 Legos to build a rectangular frame. So what this means is that she's building a frame. She's not building like a floor. So basically what this means is that when you build a frame, think of a picture frame. This is what a picture frame looks like. The inside, there's nothing on the inside. The picture frame is just the outside. So what she's doing is with her Legos, she's building a certain amount of Legos for each of these. So each of these are one Lego, and then there's a certain amount where all of these Legos are all 36. So that's what we're trying to figure out is the Legos, how many Legos. So we know how many Legos she used. We're trying to figure out how many is this side and how many is this side. So we can use X and Y. Or we can use length times width. So let's stick with length times width. So length times width. So the perimeter, if we're trying to find the perimeter, we do length plus width plus length plus width. That's the perimeter. This can simplify to 2 length plus 2 width. So what is our perimeter? 36. Remember 36 Legos to build a frame? 36. So we have 36. We can simplify this because we can divide 2 by everything. So then we get length plus width is equal to 18. Okay. So now, how are we going to solve for length or width? So remember, this is our equation. Length plus width is equal to 18. So what we want to do is we are going to, on the side, we're going to let L equal X. When we do that, then we get this new equation where our width, so if L is X, we get X plus W is equal to 18, or W equals 18 minus X. So what do we do with that? We're going to make the area. Remember, area is equal to length times width. So in this case, our area is equal to X times our width, which we said is 18 minus X. So this is our quadratic formula, or sorry, not our quadratic formula. This is our quadratic function. We need to put them in X and Y to make it a quadratic function. So what we are going to do now is find the x-intercepts. So remember, x-intercepts are when our y is 0. So let's set this equation equal to 0 and find our x-intercepts. Well, we get 0 is equal to x and 0 is equal to 18 minus x. So x is either 0 or x is 18. So our graph, remember our x, this graph is going to look like this. X squared, or here, so our graph is going to look like, we have, let's multiply it out. So x times 18 becomes 18x, and then x times negative x, so minus x squared. So if you guys want to put it in your calculator, you can put it in your calculator, or I can show you. So it's going to look something like this, where our graph, remember, since our x-intercept is at 0, and then our second x-intercept is going to be at 18. And since our x squared is negative, it's going to be concave down. That's just a rough graph of what we just did. Our vertex is over here. Our vertex is in the middle. What's the middle of 18? 9. Half of 18 is 9. So since our vertex is at 9, this is our maximized area. This is the maximum over here, or 9. So this question's a bit tricky because it's asking for the largest possible area. So that's why we have to do all of this to find out the 9, where the maximum is. So now we know that our x value is 9. Our x has to be 9. So we found the minimum values, and we just found the maximum value, which is 9. That was the whole point of this, our maximum. So now that we found that x is equal to 9, we're just going to plug it back into our equation. So we said we're going to let L equal x. If x is equal to 9, then our L equals 9. Then we're going to do our x plus w is 18, or our w is equal to 18 minus x, which means our w is equal to 18 minus 9, or our w equals 9. So now that we found our L is equal to 9 and our W is equal to 9, the last step we have to do is find the area. So what is the area? Remember, area is length times width. So our length we said is 9, and then our width we said is 9. So 9 times 9 is 81. So our area is 81. And that's our answer, 81. It was a lot of work, but just to summarize this, she's finding a rectangular frame. So that's why we knew it was perimeter, because she's finding a frame. Then we had to write a function to model the length of the side, and we had to maximize it to find out what our largest possible area. So we had to find the maximum, which was 9. Then we can find 9 times 9, which is 81, which is our area. Okay, so question number 3. Does the table of values below represent a quadratic equation? So let's see. So what I like to do is, the difference between a quadratic and a linear is that a linear has the same slope. Remember, our linear equations are in the format y equals mx plus b. Our slope is the same for every point. It's m. Our slope will always be m. However, quadratic equations, remember, are going to be in the form x squared, or it's going to be in the form ax squared plus bx plus c. There's always going to be the x squared. So we need to figure out if the slope is the same, and if it is, then it's linear. If the slope is not the same, then it's going to be quadratic. So how we can do this, let's move all of this stuff. Okay, I can't move it, so I'm just going to erase it all. So let's erase everything and start by manipulating the table. So what do I mean by manipulate the table? Well, let's look at our values. Let's zoom in really close. So going from our x from -1 to 0, we're going to find the slope. So we're going to do the change in our y values. So f of 0 minus f of -1 all over 0 minus -1. So what is our f of 0? Our f of 0 is 6. Our f of -1 is 4. So 6 minus 4 all over 0 minus -1, 0 plus 1. We get 6 minus 4 is 2 all over 1. We get 2. So the first one's 2. So now let's do this again. For the next one, we have 11 minus 6, 11 minus 6 over 1 minus 0. 11 minus 6 is 5. 1 minus 0 is 1. So then we get 5. So now we're seeing, we have 2 and we have 5. So I'm going to assume that we do not have a linear equation. But let's continue. So this is not linear because we have different slopes. But let's continue. So then we have, for this one, we have 19 minus 11 all over 2 minus 1. So then that gives us 8 over 1, 8. The last one we have 32 minus 19 all over 3 minus 2. 32 minus 19 is 13 over 1, 13. So now we have 2, 5, 8, and 13. So what do you think? I'm going to give you a second to think. Is this a quadratic equation? Okay. So, did you think about it? Do you think you have an answer? So the trick is we did all this, but now what is the difference between these two numbers? 3. What is the difference between these two numbers? 3. Okay. What's the difference between these two? 5. So, what does this mean? This means that, so even though we thought that it varies by 3, because we got 3 once, 3 twice, and then now 5, the difference in the last two is 5. So, the rate of change our slope is not linear. Therefore, this is not, it's not quadratic. So, the question says, does it value represent a quadratic function? No, it does not. That's question 3. Okay, I'm going to pause the video here, and then we are going to get to prerequisite number 7 in the next video.